Alright, in this video we are going to talk about Boolean Algebra. And Boolean Algebra is a way of looking at how different Boolean operators, such as the OR statement or the the OR operator or the AND operator, combine to get different outputs. And some of these are not as obvious as others, such as like maybe this one, but I'll try to make it clear in how you can interpret this. And recall that A can only be 0 or 1, B can only be 0 or 1, and hence they're binary values. And Boolean algebra is the algebra of binary values. Okay, so here we have A or B, and that's equal to B or A. And recall that the OR operator said, well, if one of these is 0 and the other one is 1, then we get a 1. So if A is 0 and B is 1, or if B is 0 and A is 1, we still get a 1. Okay, over here, this is A and B, and that's equal to B and A. And so, if A is 1 and B is 1, we get a 1. If B is 1 and A is 1, we get a 1. If there's any other case, then we get a 0. A 0 times whatever the other value is would be 0. Okay? So we can look at the truth table for this real quick. So if we had an A and a B, and if A is 0 and B is 0, or A is 0 and B is 1, or A is 1 and B is 0, or A is 1 and B is 1, okay, then you can see that if A is 0, okay, then A and B is 0 for both cases. If B is 0, we get a 0. And only when they're both 1 do we get a 1. Okay, so this basically just shows that A and B is B and A, which makes sense if you think of it in terms of zeros and ones. Down here, A or 0 will give you a 0 if A is 0. So if A is 0, you get a 0. It will give you a 1 if A is 1. So 0 or A or 0, it gives you A. A and 0 gives you 0 because you have to have, just like for this column here, in order for you to have a 1 over here, you have to have a 1 and a 1. So anything and a 0 is 0. A and 1 is 1 because we already have, A or 1 is 1 because this is the OR operator, and one of them is already 1, so you're going to get a 1. A and 1 is A, because if A is a 0, you get a 0. If A is a 1, you get a 1. A or A, so if A and A are both 1s, you get 1. If A is 0 and if A is 0, then the right hand side is also 0. So A or A is equal to A, which is kind of interesting. A and A is not A squared, it is just A. Okay, because we're doing Boolean algebra on binary values. This just says 1 and 1 is 1. Okay, you can kind of think of it as 1 times 1 is 1, but it's really 1 and 1 is 1. This says A or not A, and it equals 1, because if A is 0, then this is 1, and when this is A or not A, one of them has to be 1, and the OR operator says if one or the other is 1, then you get a 1. Okay, this is the law of complements. A not A gives you 0, because if A is 0, then this is 1. So if A is 0, okay, then this has to be 1, so you get a 0, and if this is 1, this has to be a 0, so you get a 0. Okay, so that is real quick how you go through and try to interpret the Boolean algebra. Now this might not be intuitive. This is a not, so if A is 1, then the first not makes it a 0, the second not makes it a 1. So it's the same thing as it was originally. Alright, and you can go down here and look at some of these, and some of these are not as intuitive, and so what you could do is actually build a truth table, which we have done for number 16. Number 16 says A or A and B is equal to A. All right, so we'll prove this one down in a truth table here in just a second. Let's just take this operator and let me show you what you can do here. So we have A or A and B equals A, and it may not be intuitive how that actually works out, but we are allowed to pull out the A, and then we can have a 1 or B and see what that equals to. Well, this OR statement says 1 or B. Well, you have a 1 there, so this is always going to be equal to 1. So then you have an A and 1 is equal to 1. All right. Instead of doing that, though, what we could do is we could bring this down and take a look at this truth table for law 16. All right. So we could do all the different combinations of these. We could look at A, B, and C values and assign values to each one of them, A, B, and C, and cover all possible states that these values could have. So there's 1, 2, 3, 4, 5, 6, 7, 8 states because we have 3 variables that can take on 2 values. So we have 2 to the 3 possible conditions, and we can look at each condition. All right. So sometimes with more complicated statements, it's important to break them down into each one of their statements, and then we can easily sort of see the combined statements. And in this case, we're trying to prove this 16, this law, and through the truth table. So if we look at A, B, and C, we can look at A and B. All right. So we have these OR statements, and we have A, or B, and C. Okay, so over here we can look at B and C. So all these, this is going to be 0 because that's 0. This is going to be 0 because B and C is 0. And then this is going to be 0 because C is 0. So that gives you these 3 zeros here. And then down here we are looking at A or B and C. Well, B and C, this is going to give you a 1. Okay, so you get a 1, and A is 1 for the rest of these, so it doesn't matter what these are because we have an OR statement and they're all going to be 1. All right, it turns out that that's also equal to A and A or B and A or C is also equal to A or B and C. So these are just some pretty much a quick overview of how do you look at these Boolean algebra expressions, and if you need to, how you can prove them.